Welcome to our lesson on coordinate geometry. In this video, we'll explore the fascinating world where algebra meets geometry, allowing us to solve geometric problems using algebraic techniques. Let's begin by outlining what we'll cover in this lesson. We'll start with the Cartesian coordinate system and quadrants. Then we'll learn the distance formula. Next, we'll see how to find the area of a triangle using coordinates. And finally, we'll cover the section formula, which helps us find the coordinates of a point that divides a line segment in a given ratio. But first, what exactly is coordinate geometry? It's a system of geometry where the position of points on a plane is described using an ordered pair of numbers. These ordered pairs are called coordinates. This method was proposed by the French mathematician René Descartes. He was the first to link algebra and geometry by showing that curves and lines could be described by equations using this technique. In honor of his work, the coordinates of a point are often referred to as Cartesian coordinates, and the coordinate plane as the Cartesian coordinate plane. Now, let's visualize the Cartesian coordinate system. It consists of two perpendicular number lines called axes. The horizontal line is the x-axis, and the vertical line is the y-axis. The point where these axes intersect is called the origin, and it's usually labeled as O. The positive x direction extends to the right, and the negative x direction extends to the left. Similarly, the positive y direction extends upward, and the negative y direction extends downward. Let's review some basic points about the coordinate system. To locate the position of a point on a plane, we need a pair of coordinate axes. The distance of a point from the y-axis is called its x-coordinate, or abscissa. The distance of a point from the x-axis is called its y-coordinate, or ordinate. Points on the x-axis have coordinates of the form x, 0, while points on the y-axis have coordinates of the form 0, y. The coordinate plane is divided into four quadrants by the x and y-axes. These quadrants are labeled counterclockwise using Roman numerals. The first quadrant, where both x and y coordinates are positive, is denoted as quadrant 1. The second quadrant has negative x and positive y coordinates. The third quadrant has both negative x and y coordinates. And the fourth quadrant has positive x and negative y coordinates. Points that lie on any of the axes don't belong to any quadrant. Now, let's derive the distance formula, which allows us to find the distance between any 2 points in the coordinate plane. Consider 2 points P with coordinates x1, y1, and Q with coordinates x2, y2. We can draw perpendiculars from these points to the x-axis and then connect them to form a right triangle. Let's call the point where the perpendicular from P meets the line through Q parallel to the x-axis as T. Now, the side PT is the difference in x-coordinates, which is x2 minus x1. And the side QT is the difference in y-coordinates, which is y2 minus y1. Using the Pythagorean theorem in triangle PTQ, we get PQ squared equals PT squared plus QT squared. Substituting the values, we get PQ squared equals x2 minus x1 squared plus y2 minus y1 squared. Taking the square root of both sides, we get the distance formula. The distance between points x1, y1 and x2, y2 equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Let's now apply the distance formula with an example. Find the distance between points P, 1, minus 3, and Q, 5, 7. Substituting into our formula, we get distance equals square root of 5 minus 1 squared plus 7 minus 3 squared. This simplifies to square root of 4 squared plus 10 squared, which is square root of 16 plus 100, which is square root of 116. Taking the square root, we get approximately 10.77. A special case of the distance formula is finding the distance from a point to the origin. When one point is the origin 0, 0, the formula simplifies to the distance equals the square root of x squared plus y squared. The distance formula has many applications in coordinate geometry. We can use it to check what type of triangle is formed by 3 given coordinates. By calculating the lengths of all 3 sides, we can determine if the triangle is equilateral, isosceles, or scalene. We can also check if it's a right triangle using the Pythagorean theorem. Similarly, for quadrilaterals, we can determine whether it's a square, rectangle, rhombus, or parallelogram by checking the relationships between side lengths and diagonals. We can also use the distance formula to check if 3 points are collinear. 3 points A, B, and C are collinear if they lie on the same straight line. One way to check for collinearity is to see if the sum of two distances equals the third distance. That is, if A, B, and C are collinear, then either AB plus BC equals AC, or AB plus AC equals BC, or BC plus AC equals AB. Let's now move on to the section formula, which helps us find the coordinates of a point that divides a line segment in a given ratio. Consider a line joining 2 points A, x1, y1, and B, x2, y2. Let P, x, y be a point on this line that divides the line segment AB in the ratio m1 to m2. This means that the ratio of AP to PB is m1 to m2. By using similar triangles and the properties of proportions, we can derive the section formula, which states x equals m1x2 plus m2x1 divided by m1 plus m2, and y equals m1y2 plus m2y1 divided by m1 plus m2. A special case of the section formula is the midpoint formula, which gives us the coordinates of the midpoint of a line segment. When a point divides a line segment in the ratio 1 to 1, it's the midpoint of the line segment. Substituting m1 equals m2 equals 1 in the section formula, we get the midpoint formula P equals x1 plus x2 divided by 2, y1 plus y2 divided by 2. Now, let's see how to find the area of a triangle using the coordinates of its vertices. Consider a triangle ABC with vertices ax1, y1, bx2, y2, and c, x3, y3. We can find the area by dividing the coordinate plane into convenient shapes and using the properties of areas. After some algebraic manipulation, we arrive at this formula for the area. Area of triangle ABC equals absolute value of half of the determinant x1 times y2 minus y3 plus x2 times y3 minus y1 plus x3 times y1 minus y2. This can also be written in a more compact determinant form, which is easier to remember. As an interesting application of coordinate geometry, you can try this project. Mark coordinate axes on a map of your city and find distances between important landmarks like the bus stand, railway station, airport, hospital, school, your house, and any nearby river. This will give you practical experience with the distance formula in a real-world context.